Two objects, one of mass 10 kilograms and the other of mass 6 kilograms, are attached to the ends of a light, inextensible string passing over a smooth, fixed pulley. The objects are released from rest 2 meters above the ground. So if this is our pulley, actually let's draw that a little bit bigger. And these are the two masses. So we've got, this one is 10 kilograms and this one is 6 kilograms. And here's the ground, and we know that this distance here is 2 meters. Clearly, when we release this from rest, the 10 kilogram object is going to accelerate downwards and the 6 kilogram one upwards. So we know that there'll be a weight 10g acting this way, 6g acting this way, and then there'll be the tension in the string, which, because of the string being light and inextensible and the pulley being smooth and fixed, the tension will be the same throughout the string. We know the system will accelerate this way. So, in part A, if we look at, let's call this one A and this one B, if we consider A, F equals ma gives us that 10g take away t is going to be equal to 10a. If we look at B, F equals ma will give us that t minus 6g is equal to 6a. And if we add equations 1 and 2, the t's will cancel out. 10g take away 6g is 4g is equal to 16a, and therefore a is going to be 4g divided by 16. If we take g is equal to 9.8, we've got 4 times 9.8 divided by 16 gives us 2.45 meters per second squared. Now we're asked, what is the greatest height above the ground that the 6 kilogram object reaches in the subsequent motion? So let's think about the subsequent motion. This one's going to shoot down until it hits the ground. This one will shoot up until this one hits the ground. At which point this one will be 4 meters above the ground and traveling upwards with some speed v. It will then continue to move under gravity because at this point the string will become slack. So what we really want to know at this point is v. So we have a suvat. We know it's going to travel for 2 meters. We know it was released from rest, and therefore u is 0 meters per second. V is what we really want to find, and we know the acceleration is 2.45 meters per second squared. These quantities are linked by v squared is u squared plus 2as. Therefore, v squared is 0 plus 2 times 2.45 times 2. So v squared is going to be 9.8, and v is then going to be the square root of 9.8, which is about 3.13 meters per second. Now at this point it starts to travel freely under gravity, which is another suvat. is going to travel from 3.13 meters per second, and at its greatest height, this would be 0. We really want the distance, and we know that once it's freely under gravity, that's negative 9.8. So we have v squared equals u squared plus 2as again. So 0 is going to be, well, we know that u squared is 9.8. And then we're going to have, if we know that a is negative 9.8, so that's going to be 19.6 s. And so s is going to be 9.8 divided by 19.6, which is 0.5. And therefore, the greatest height is going to be, remember it was 4 meters above the ground, and then it travels a further 0.5, so that's going to be 4.5 meters.